Okay, welcome back. Today we're going to be reviewing page 8 and then page 51 in the notes. So I put a link in here to the periodic table so you can find things. And we're going to be doing the same thing we've been doing. We're going to find sodium and sulfur on the periodic table. So we look over here, and we found sodium enough. Okay, it's in family 1 and has an oxidation number 1. Here's sulfur is in family 6. Then it has an oxidation number of 2 negative. So we're going to use that information here. Sodium is Na, and sulfur is S. Sodium is in family 1, has 1 valence electron, and we said the oxidation number for family 1, 2, and 3 was the same as the family number, so it's a 1. Okay, sulfur is in family 6. So it's in family 6, that means it has 6 valence electrons, and we said the oxidation numbers for family 5, 6, 7, and 8 were the number of electrons needed to get to 8. So we have 6 as the family number, and it's going to take 2 negative electrons to get to a total of 8. So step 1, write the symbol with its oxidation number. We have the Na, and we write its 1 plus. We have the sulfur, and we write its 2 negative. Okay, now to come up with the formula, okay, we are going to use the same symbols, Na and then S. Now we're going to take this 1, and we're going to stick it down over here. We're going to take this 2, and we're going to put it here. Okay, and we drop the signs when we make a formula, like water doesn't say 8 plus 2 or something. All right, so we have the 2 that came down over here, the 1 that came down over here, and the name of the compound is going to be sodium, and we put IDE on the end of this one. Sodium sulfide. Usually you go to the first vowel. Okay? Now, barium and iodine. If it says IDE, that's INE on the end, it's in family 7. So this family 7, family 7, family 7. Okay, so we need to find barium and iodine. Okay, barium is right here in family 2, and iodine is in family 7. All of these end in INE. So barium symbol is Ba, and it's in family 2, and so it has 2 valence electrons. Families 1, 2, and 3, the oxidation number is the same as the family number. Iodine symbol was I. It's in family 7, 7 valence electrons, and its oxidation number is going to be 1 negative. So when we come up with the formula, we're going to take the symbol, and we're going to write its oxidation number 2 plus, and we're going to write iodine, and its oxidation number is 1 negative. To make the formula, we use the same symbols, barium and iodine. And this is where we do our crisscross. We're going to take this 2, and we're going to stick it over here. We're going to take this 1, and we're going to put it right there. So the 2 goes down over here, and the 1 goes down over here. And that's it. Just crisscross and drop the signs. So now the name of the compound is barium, and we never change the name of the first one. And we put IDE on the end of the second one. So it's barium iodide. Okay, now the next one says do aluminum and bromine. Okay, so we have to find aluminum on the periodic table. Remember, aluminum is a metalloid by position. It's right here in family 3. And its oxidation number is 3 plus. And I said anything that ends in INE is over here in family 7. Its oxidation number is 1 negative. So we're going to take our symbol is aluminum, and it's in family 3. So it has 3 valence electrons. Family 1, 2, and 3. The oxidation number is the same as the family number. Bromine symbol is Br, and it's in family 7. It has 7 valence electrons, and its oxidation number is the family number, and then the number of electrons it takes to get to 8. Well, we have 7. It takes 1 negative electron to total 8. 7 plus 1 is 8. So we come over here, and we're going to start off with symbols in the oxidation number, and we're just using the information that we gathered up here. Aluminum is the symbol, its oxidation number is 3+. And then we have bromine, and its oxidation number is 1 negative. Now to make the formula, we're going to use the same symbols, aluminum and bromine. And then we do the crisscross and dot signs. So we're going to take the 3, and it goes down here by the bromine. We're going to take the 1, and it goes over here by the aluminum. So we're going to put the 1 here, and we're going to take this 3 and stick it down and across right there. And the name of the compound is going to be aluminum. And we put IDE on the end of the bromine. So it's bromide. Once you get the hang of this, it's pretty simple. Okay. Sodium, we already know its symbol is Na. We found it up here. Okay, and it's in family 1. It's 1 valence electron. Its oxidation number is 1+. Fluorine is in Ne, so it's in family 7. It has 7 valence electrons, and its oxidation number is going to be 1 negative. So we just use the information we gathered here. We have Na with 1+. We have fluorine with 1-. So to make our formula now, we have the same symbols, Na and F. And we're going to take this 1 and stick it down over here, and we're going to take the other 1, that one there, we're going to put this one here. So a 1 is going to go in both of these boxes. And that's it. And the name of our substance is going to be sodium fluoride. We just put IDE on the end of the second one. And then the name of this other one is lithium and nitrogen. So we got to look at the periodic table and find lithium and nitrogen. So here's lithium. It's one of the alkali metals. It's in family 1. And then it said to find nitrogen. Nitrogen's over here in family 5. It's going to have an oxidation number 3 negative. So we're going to put the symbol for lithium, and it's in family 1, so it has 1 valence electron, and the oxidation number is the same as the family number. And nitrogen is in family 5, so it has 5 valence electrons, and we need 3 to total 8. So we're going to write the symbol and oxidation number, and we're going to write the other one and its oxidation number. Now to make our formula, it's going to be Li something, N something, and we're going to take this 1, this is where we do the crisscross, drop the signs, this 1 is going to go right here, and this 3 is going to go down over here. So we're going to take and put the 3 here where we said, it went down and across, and the 1 where it went down and across, and the name of the compound is going to be lithium. We never change the name of the first one, and then the name of the second part, we put IDE on the end, so it's nitride. And that's it. Okay, so we said we would do page 51 in the notes. Now, on page 50 is this periodic table, and down here is some polyatomic ions. And you see NH4 is a 1+, and then it has this acetate, this chlorate, this hydroxide, this nitrate, this bicarbonate. And over here with oxidation number 2 negative is this carbonate, this sulfate, and then the 3 negative is this PO4. Now, these polyatomic ions work exactly the same is the elements. So like Na was 1 plus. So this whole thing inside the parentheses, think of this like an element symbol. Okay, so this whole thing inside the parentheses is the 1 plus. Just like when you wrote sodium with its 1 plus, you did not change the name of sodium or do anything to it. You are not going to do anything to these things inside the parentheses. So this whole thing, the C2H3O2, is a 1 negative. You write the whole thing just like the other things that were 1 negative was fluorine, bromine, chlorine over here. And you didn't change the symbol name. Think of this whole thing in the parentheses like a symbol name. Same thing with the chlorate, the OH, all of them. So here, like everything in family 6 was a -2, this whole little group of atoms is a -2. So think of this, everything in the parentheses, just like an element symbol. Okay, so we're going to take a look at these polyatomic ions. Poly means many. So down here, or many or more than one, are these polyatomic ions. It's the same as the chart I just showed you. So it means many atoms. So it's an ion that's made up of more than one atom. They work just like what we've been doing with the binary compounds with single elements. We're going to write the name of the positive ion first, followed by the name of the negative ion. So let's take a look at the example. Okay, so it says, write the formula for magnesium chlorate. We know magnesium is an element, and it's in family 2. So let's take a look at the periodic table. Magnesium is an element, it's in family 2, and it has an oxidation number of 2. Chlorate is right here. It's CO3, and it has an oxidation number of 1 negative. Magnesium with its oxidation number of 2 positive. Magnesium is in family 2, so it has an oxidation number of 2 plus. Chlorate is right here. It's ClO3. And we write everything in the parentheses, and we don't mess with it. Just like it was an element symbol. You're going to change the name of the element, you're not going to change the symbol. You don't change the letters, you just don't mess with it. So think of the whole parentheses and everything in it, just like it was a symbol. Okay? It has an oxidation number of 1 negative. So we do the same thing. We write the name of the positive one with the oxidation number with superscript, and then we write the name of the negative one with the oxidation number of superscript. We're going to move the 1 down here and the 2 down over here, so we end up with the Mg1 and the ClO2. The 2 goes on the outside of the parentheses, just like the whole thing was an element symbol. Okay? So that's the 2's going to go over and across, the 1's going to go down and across, and then remember we said if there's no number, the 1, you don't have to put it there. So let's look at some. Okay. We're going to write the name of the positive ion with its oxidation number, and then the negative ion with its oxidation number. So this is potassium and chlorate. So we're going to look here. I made a little cutoff part on the periodic table. And there's potassium, is in family 1, and it has an oxidation number of 1 positive. We're going to find a chlorate. We're going to get me out of the way and find chlorate. So over here in this table, it's ClO3, and it has an oxidation number of 1 negative. So we're going to write the ClO3, and we're going to think of this whole thing just like it was an element symbol. This is one thing. We leave it in the parentheses. We don't touch anything about it, just like you didn't mess with the element symbols. It has an oxidation number of 1 minus. Okay? So we write K with its 1 plus. ClO3, but it's 1 minus. We're going to take the 1 and stick it down over here by the K and drop the sign. We're going to take the other 1 and stick it down over here on the outside of the parentheses by the ClO3. Remember, this whole thing works just like as if it was an element symbol. So we're going to put the 1 right there. We're going to put the other 1 right there. And our formula is going to be K1 ClO3 1. So, again, this whole thing is like an element symbol. With every parentheses and everything in it, you don't touch. And the next one says to do ammonium hydroxide. This is actually drain cleaner, so you might have some in your house. We look up here, ammonium. Oh, and the name of this compound, we don't have to do anything with IDE. It's just potassium chlorate. So if it's a polyatomic ion, it's actually easier to name it because it is just what it is. Now this ammonium is the whole thing, the NH4, the parentheses, and everything in it is a 1 plus. And the hydroxide, the OH, the parentheses, and everything in it is a 1 minus. So we found the NH4, and this works just like the K did, just like an element symbol. We didn't mess with the K. We're not going to mess with anything in the parentheses. It's a 1 plus. The OH is a 1 minus. So now, just like we've been doing, we write the NH, what is 1 plus. This information that we gathered right here. We take the OH, and we write it with this 1 negative. And what have we been doing? We're going to take this 1, and we're going to move it down and across and drop the sign. We're going to take this 1 and move it down and across and drop the sign. So it goes right there. This whole thing, the whole parentheses, works just like an element symbol, so the 1 is going on the outside of it just like if it was a symbol, and this other 1 is going to be right here. So the final formula for this compound is going to be NH1, OH1. So again, the whole parentheses and everything in it works just like as if it was a symbol. This next one says to do potassium and carbonate. So potassium is an element. So we look on the periodic table here. It is in family 1, and it's a 1 plus. So we have the potassium, and its oxidation number is 1 plus. Carbonate does not sound like any element we worked with. So we look over here, and we find carbonate is CO3, and it has an oxidation number of 2 negative. So we're going to write the CO3 and its oxidation number. So now to make the formula, we write the potassium, where it's 1 plus. We write the carbonate, where it's 2 minus. What do? We crisscross the numbers. So we're going to take that 2, and we're going to stick it right down there, and we're going to take the 1 and crisscross it over to here. And we drop the signs. There's not positive and negative signs in a formula. Like H2O is just H2O. It's not H2 positive or O1 negative or something. There's no signs in a formula. So we have K2, and we're going to have the CO3 with the 1 on the outside. The CO3 with the 1 on the outside. So there's nothing new about this. Okay, it's exactly what we've been doing. We just write the 2 things, crisscross the numbers. These are a little easier because if the second one is a polyatomic ion, you don't need to change the name. So you're going to need to refer your notes into this chart in order to do your assignment. And we'll see you next time.